Good afternoon, ladies and gentlemen. My name is Bernard Septian. I'm honored to present my research titled Evaluation of Core Dam Foundation Improvement using a cut-off-wall and curtain grouting methods. This study was presented as a part of the third International Conference on Geotechnical Hazard and Mitigation, which is 2025. And the research focused on assessing seepage behavior in the core foundation of the Tugu Dam, East Java, and evaluating the effectiveness of two improvement techniques, cut-off wall and curtain grouting. Geological investigations show that the colluvial in the core foundation extend more than 20 meter deep. This layer is relatively porous, resulting in a high uplift force and reducing the reservoir storage efficiency. Then, in addition, the dam height reaches over 80 meters from the base of excavation, which increases hydraulic pressure on the foundation. The foundation became that effect, the foundation became more porous with the following impact. First, generate a high uplift force, and then the storage capacity become inefficient. Therefore, it becomes necessary to evaluate appropriate foundation improvement methods, particularly the use of a cut-off wall and curtain grouting to minimize seepage through the core zone. This study was conducted to address three main research questions. First, how can we determine the seepage rate occurring in the dam's core foundation? Second, how can simulation-based approaches improve seepage control performance? And third, what are the comparative results between the existing condition and the simulated configuration of cut-off wall and curtain grouting in the core foundation? The objective of this research are as follows. First, to evaluate the magnitude of seepage rate in the existing foundation. Second, to perform simulation that optimize the thickness of the cut-off wall and the spacing of curtain grouting points in order to reduce seepage. And the last, to compare the seepage rate between the existing foundation and the simulated improvement.
Study was carried out at the Tugu Dam, located in the Trenggalek Regency, East Java. The data were obtained from geological investigation and permeability region test. Numerical modeling of the seepage was performed using GeoStudio Seep, a finite element modeling software widely used for geotechnical analysis. Several simulations were conducted with the cut-off wall thickness variation of 1.0 meters, 1.3 meters, and 1.5 meters, and the results were evaluated according to the POPR 2025 grouting guidelines. This figure is a discrepancy in the delineation of the colluvial layer boundary as illustrated in the cross-sectional profile. The dam foundation mainly consists of colluvial and alluvial layer, both exhibiting high permeability, approximately 1 times 10 to the negative 4 centimeter per second. And for the slope stability, the excavation was limited to elevation 156 meters. Due to the porous foundation material, subsurface improvement below the core zone was required. Cross-sectional profile indicated differences in the delineation of the colloquial boundary, reinforcing the need for the detailed foundation treatment. The design parameters were determined from both field and laboratory permeability data. The highest permeability values were selected for the foundation layer to represent critical seepage condition. For the embankment zone, average laboratory permeability values were used. These parameters were incorporated into the finite element seepage model for further analysis. Based on a geometric model and permeability data, the seepage analysis of the existing condition indicated the discharge rate exceeded the allowable limit, and the total seepage is 15.45 liter per second, and then two seepage criterion. Number one, less than 0.05% of the total reservoir volume per day, with limit for 56.89, and the conclusion satisfies criterion. And then number two, less than 1% of the average inflow discharge with limit 13.20 liter per second, and the conclusion does not satisfy. And then the foundation improvement is required. Several improvement simulations were conducted, including 1 meters, 1.3 meters, and 1.5 meter diameter cutoff walls, all combined with curtain grouting, and then 1.45 meter diameter cutoff walls with and without grouting contents. Through a trial and error process, the 1.45 meter configuration was identified as the optimum diameter for achieving the most efficient seepage reduction. The results show that the combined application of cutoff wall and curtain grouting effectively reduced seepage by approximately 15%. The 1.45 meter cutoff wall with the curtain grouting configuration provided the best performance, meeting the allowable seepage criteria set by the PUPR 25 guidelines. However, a small amount of residual seepage was observed beneath the wall, which can be attributed to porous colloquial deposit and existing drop joints. These results are consistent with the previous finding by Dharmayasa 2018 and Tosun 2018, who reported similar improvement in the seepage control using combined methods. The dam foundation configuration. This is the dam foundation configuration after the implementation of the improvement measure is presented as follows. As shown is in this figure, the improvement zone extends below the core foundation, demonstrating the seepage flow path after treatment. And then this is a long section. This is a cross section. In the conclusion, this research demonstrated that before improvement, the seepage discharge was
15.45 liters per second. After simulation, it was reduced to 13.19 liters per second. The optimized 1.45 meters cutoff wall combined with the curtain grouting successfully met the allowable seepage limit. Therefore, this combined wet method is recommended for the future dam project built on porous geological foundation. Thank you very much for your attention. I would be happy to discuss any question or comment.